Day 616 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 865, smallest subtree with all the deepest nodes. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the root of a binary tree, the depth of each node is the shortest distance to the root. Return the smallest subtree such that it contains all the deepest nodes in the original tree. A node is called the deepest if it has the largest depth possible among any node in the entire tree. The subtree of a node is a tree consisting of that node plus the set of all descendants of that node. Alright, y'all, so let's go ahead now that we've read the question and take a look at these examples just to make sure that we are doing the question correctly. So in example 1, we have this binary tree, input binary tree root, which is a binary tree 35162080074. The output is 274. So let's break that down one step further and take a look at the explanations to see what they did here, right? Because we know that we want to find the deepest, the deepest nodes, and we want to find the smallest subtree. So let's see what the smallest subtree is with the deepest nodes, and that is 274. That's this right here. And the explanation says we return a node with the value 2, colored in yellow in the diagram. Boom, that's this 2. So that's the root of the subtree, the smallest subtree with the deepest nodes. Then the nodes colored in blue are the deepest nodes of the tree. Notice that nodes 5, 3, and 2 contain the deepest nodes in the tree, but node 2 is the smallest subtree among them, so we return it. So let's break this down one step further, right? So we want the deepest node. So if we look at this subtree right here that they give us a picture of, we see that this 7 and 4, these are the deepest nodes, right? We can see that because there are no other nodes on this level or beneath this level, right? So we know 7 and 4 are the deepest nodes. Then we want to find a subtree because we need to include all of the deepest nodes, right? So 7 and 4 are all of the deepest nodes, so we need the subtree that connects them. 2 is the root node of this subtree that connects 7 and 4, right? So that is the smallest subtree that we can create with this, using this 2 as the root, and then 7 as the left child, and 4 as the right child, and this is the subtree that we return. Boom. Now say we had more nodes right here. Say 0 had let's just say it's a 1 right here and a 2 right here. Then the whole binary tree would be the smallest subtree that we created, because once again we need to include the tree consisting of the node plus set of all descendants of that tree. So if we were to have some nodes right here, this subtree and this subtree will not be connected yet. We could go up a level and they will still not be connected yet, but we still would need to include these descendants of these nodes, and it wouldn't be connected until we got to this tree, this 3, which would be the whole subtree, right? So that's just an example of if we did have nodes over here. But since we don't have nodes over here, we could just create the smallest subtree starting at this 2 for the head, and then once again, or the root, and then 7 and 4 is the children nodes. So just in case that didn't make sense, let's take a look at example 2. In example 2, we have our input root binary tree, just one node. The output is just one node. It said the root is the deepest node in the tree. So the root is the only node, therefore it's the deepest node, so we just return the root. Boom. Then in example 3, we have root equals an array of integers, a binary tree 0, 1, 3, null 2. This time the output is 2. It says the deepest node in the tree is 2. The valid subtrees are the subtrees of node 2, 1, and 0, but the subtree of node 2 is the smallest. Boom. So that's more like if we say we had up here, say this 4 wasn't right here. then this 7 would be the deepest node and its own subtree, because we wouldn't need to connect the 7 to anything else, because it would be the deepest node by itself, right? So that's what example 3 is talking about, is if this 4 wasn't right here and it was just this 7, then this 7 would be the smallest subtree and the deepest node, so that would be the only thing we return. But in this case, it's 2. Boom. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we're going to do is we are going to come underneath this function right here, and we're going to create a depth first search helper function. So for that, we can say func dfs, open up the parentheses, underscore node, colon, tree node, question mark, comma, underscore, depth, colon, int. Come outside of that, it's going to return, open up the parentheses, a tree node, question mark, comma, int. Come outside of that, and we're going to open up the brackets. Now we're going to handle our base case. If the node is nil, we could just return nil and the current depth. So we could say guard let node else, open up the brackets, and we could return nil, comma, depth. Boom. Then we're going to come underneath that, and we're going to recursively process the left subtree, increasing the depth. So we're going to say let left equal dfs, open up the parentheses, node dot left, comma, depth plus 1. Boom. Then we're going to recursively process the right subtree, increasing the depth. So we're going to come underneath this, and we're going to say let right equal dfs, open up the parentheses, node dot right, comma, depth plus 1. Boom. If both subtrees have the same maximum depth, then the current node is the lowest common ancestor of all the deepest nodes. So we'll come underneath this, and we'll say if left dot 1 equals right dot 1. We'll open up the brackets, and we'll return, open up the parentheses, node, comma, left dot 1. Boom. Then we'll come underneath that, or right here, and we'll say else, open up the bracket. If the left subtree is deeper, we're going to propagate the left subtree's result upward. So we'll say else, we'll say else if left dot 1 is greater than right dot 1. Then we'll come right here, and we'll return, open up the parentheses, left dot 0, comma, left dot 1. Boom. Then if the right subtree is deeper, we'll propagate the right subtree's result upwards. So we could come right here, and we'll say else, open up the brackets, we could return, open up the parentheses, right dot 0, comma, right dot 1. Boom. Then, or actually, y'all, that should be all she wrote for that, because we need to come up here to the main function, and we need to call this helper function. We could just say dfs, open up the parentheses, pass in root, comma, 0, come outside of that and say dot 0. Now that should be all that she wrote. Let's go ahead and give this a run. Okay. Let's see where we went wrong here. Oh, this should be in parentheses, y'all. Sorry about that. So go ahead and run it again. Let's see, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So With that being said, I hope y'all learned something today. Matter of fact, before we go though, make sure you get one more look at the code. This is the top part. Or actually, this is the whole code right here. So yeah, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.